Hello and welcome back. Let us try to understand what is skewness and what is kurtosis. When data is concentrated or data distribution is concentrated on the right side, then we call the distribution is negatively skewed or left skewed. We call this as left tailed also because the tail on the left side is big, or the distribution of the data on the left side is less and on the right side is more. So we call it as left-tailed distribution or negatively skewed distribution. If the data's density or the distribution is concentrated on the left side and on the right side the density or the distribution is less, we call that as positively skewed or right skewed data or right tailed data. So skewness can be calculated using SciPy's stats skew method. The direction of the skewness is given by the sign. When you calculate the skewness using skew method, if it is negative, that means it's a negative skewed or left-tailed distribution. If it is positive, it is positively skewed or right-tailed distribution. If it is zero, that means the data is normally distributed. The larger the negative number, the negative skewness is that huge, and larger the positive number, the skewness in positive direction is that much. The strength is given by the number calculated by the skew method. There are two formulas for skewness calculation, but we are not going into the details of the formulas, but that's okay as long as we can use skew method and calculate it. So let us try to understand what is kurtosis. When data is purely close to the mean, if the data's distribution is very close to mean, like in the red curve, then we call it as positive kurtosis. Okay, and if the data is too far from the mean, then we call it as negative kurtosis. There are two kinds of measures for calculating kurtosis. One is Fisher's way and another is Pearson's way. So in Pearson's way, the k is equal to 3. If you calculate kurtosis using Pearson way, if k is equal to 3, that means the distribution is normal. If k is greater than 3, it is positive kurtosis. If k is less than 3, it is negative kurtosis. But in Fisher's way, if k is equal to 0, then it is normal distribution. If it is greater than 0, it is positive kurtosis. If it is negative, then it is negative kurtosis. So that's all about the kurtosis and skewness in theory. Let us try to see how to use stats, SciPy's stats module and calculate these skewness and kurtosis. So you need to import the SciPy's stats module and then skew. From SciPy stats import skew. This is another way of importing a particular method. So far we have seen how to import a module, import pandas as PD. But here from a particular module we are importing a method. To do that, we need to actually do from module import skew. So we need to execute this, and then I have taken some data, a list, and passed it to skew method, and it calculated the skewness, and I have got 0.55. That means it is a little bit positively skewed. If it is 0, then normal distribution. And the second data set also a little bit of positive skew. It's almost kind of normal, but it is not positive skew. To calculate kurtosis, we need to import the kurtosis method, and then I'm passing the same data set to kurtosis, and I have said Fisher is equal to false. That means it's a Pearson way of calculating kurtosis. So I have got kind of 3.55, right? So it is almost kind of normal distribution. So close to kind of 3, right? So on the second data set, when I calculated the kurtosis, here also I have used Pearson way, and the calculated outcome is 2.04. That means it is a little bit negative kurtosis. The data is kind of a little far from mean. Okay, in this case most of the data is close to mean. So that's what the kurtosis is actually trying to explain. Thank you.